All right. So the airplane in the problem is going to be flying directly over this radar tracking system. It's not a satellite. It's a radar tracking system, in case you guys wondered. Are you guys, James, are you listening?
No.
I said James, but Zach answered, so good one. Good one. All right. If the distance between the radar system and the airplane, so that's S, the distance between those two, is decreasing at a rate of 400 miles per hour when S equals 10 miles, so they are exactly 10 miles apart, but it's decreasing at a rate of 400 miles per hour. What is the speed of the plane? And at what rate is the angle of elevation changing? Okay? So, and the angle of elevation, does anyone know where that angle would be?
It's by
the radar. It's right here, theta. Let's go ahead and label that as theta.
That's one thing I learned from
what the freak was that?
I'm sorry.
All right. So, when you look at this picture, the first thing I noticed was like, that's a right triangle. I'm comfortable with those, right? What formula would you use about this right triangle, maybe? Sokoto is going to help you with the angle, but maybe if we were like ignoring the angle for a second, what would we use with the sides?
X squared plus 6 squared.
Yeah, x squared plus 6 squared equals s squared. We like that. Right? So that's a good equation for us to have, right? Because that's what we have for a right triangle. We also know from the problem that the rate of change of s is decreasing, so it's going to be a negative number, 400 miles per hour. So I'm going to say that ds dt, the rate of change for s as time goes on, is negative 400 miles per hour. They gave me a value they're saying that s equals 10. So we do know that. Is it possible for us to figure out what x is when s equals 10? Yes, right? We can do that in the Pythagorean theorem right here. So we'll say s equals 10. We can go ahead and say x squared plus 6 squared equals 10 squared. So x squared plus 36 equals 100. So x equals 8, is that what you guys just said?
Yeah.
You guys are so fast. Okay. So we've got that. And these are all miles, right? And these problems, I think it makes it a little bit easier if you keep track of your units as you go. So that's what I've been trying to do in my answer keys when I do these. Okay. And then the speed of the plane, how fast the plane is going. If you think about it this way, the plane is like flying this direction, right? So the speed of the plane would be dx dt, because that would be how this distance is changing, right? So the speed or the velocity of the plane would have to do with this distance changing. Does that make sense? Okay, so we're going to say the speed of the plane is dx dt. So dx dt is something that we were trying to solve for. Yep, question mark. And then they also want to know the rate the angle of elevation is changing. And so that means that d theta dt is another thing that we're going to be trying to find. So we got 2 question marks there. Okay. So I'm not going to worry about the theta part yet. We don't have any equation with a theta in it. That means we're nowhere near even getting close to solving for that one. However, we do have an equation with some of that other stuff in it. So if we want to find the way that the x is changing, dx dt, we're going to go ahead and use this equation right here because it does make a relationship between the x and the s, and we do have those numbers. So what would our next step be using this equation right here? Well, we were trying to find, we have ds dt. What is ds dt? It's the derivative, right? It's the derivative of s. And we are looking for dx dt, which is the derivative of x. So what do you think we probably need to do with this? We need to find the derivative, and then we need to do something with the derivative. Okay. So what's the derivative of x squared?
2x.
2x. And what else do we have to put on it? Dx dt. And do we need to take the derivative of 6 squared? No, it's just 0, right? It's a constant. That's just a number, so we wouldn't need to do anything with that. And that's going to equal what? 2s ds dt.
So you just like put an s or an x or y with like.
And so you're saying the way that the x is changing with relationship to time, the way that the s is changing with relationship to time. Okay. So, and now at this point, we're going to plug in all the numbers that we know, and we'll solve for the thing that we don't know. So we have the 2. Do we have an x? Yes. It was 8, and we're going to put 8 miles. I'm going to keep my units in the problem. And we've got 2, and what is our s value? 10 miles. And then what is our ds dt? Okay, so negative 400 miles per hour. I did not leave enough room.
You
Okay.
did that last night too.
Yeah. Story of my life, it happens. Actually, what I did is when I wrote this first off, I actually had 3 questions to a page, and then when I was making the answer key, I was like, this is the worst thing ever, and I spread it out more. So you're welcome. I made it easier for you, but not for myself. Okay. So at this point, if we clean these numbers up a little bit, we have 16 miles times dx dt. I'm going to put parentheses around that so I don't get confused. And then over here, I've got 2 times 10 times negative 400. And what is that? Negative 8,000. And the units on this would be miles squared per hour. Oh, 1,000, right? There's another 0 there. Negative 400 times 20. I literally just typed that in a calculator. I'd say let's forget that happened, but it's on video, so that's like a real thing that's never going away. Okay, so now at this point, we can go ahead and solve for dx dt. What do we have to do to solve for it? Yeah, we're going to divide this by 16 miles. So negative 8,000 divided by 16 is negative 500. One of the miles cancels out with one of the miles up there, and that leaves us with miles per hour. And you can write it like this if you want, or you can write mph, since we know that miles per hour we often write as mph. Whichever way you write it is fine. Does it make sense for a plane to be flying negative 500 miles per hour? No. Yeah, it's in relation to the picture, and the picture is saying like the distance is decreasing, we're getting closer. And so here, when we write our answer in a sentence, let's not write it's flying a negative speed. Like it's flying back in time, folks. That'd be weird. So we're just going to say it's flying 500 miles per hour. Yeah. All right, so the plane is flying 500 miles per hour. Woohoo! That's fun. So now we have to look at the angle of elevation, and somebody already said SOHCAHTOA. And yeah, SOHCAHTOA is a good one to use here. So if we do SOHCAHTOA, I'm going to say, let's look back at our picture. Since we do know that this side is an 8, so technically you could use the 8 with the S or the 6 with the S. It really doesn't matter. But on my notes, I did the 6 with the S, so let's not throw off the teacher notes, because that's when teachers make mistakes, when they go off their notes. So are you guys okay with using the 6 and the S? Okay. So which trig ratio would we use if we have this and this one? Yeah, opposite and hypotenuse. So we're going to say sine of theta equals opposite over hypotenuse, right? And I know that for us to find this rate of change, we're going to have to take the derivative of this equation that we just wrote. And I don't want to have to do the quotient rule, so how can I fix that? Because they are asking, we can probably do it. If you do, well, the reason I put the s there is because if you put the 10, then when we take the derivative of 6 over 10, that part zeroes out. If we leave the s there, then we can use the s later. We can use that information of 10 and use that information of the ds dt and what's changing. And honestly, I'd have to look in that more to know why we shouldn't plug it in now. But that's basically why we're not, is because we do want to be able to plug those numbers in, and it takes away our opportunity to do that if we plug it in then. Yeah. It's kind of like if we had plugged in, I guess you're not plugging s in here because s could change. It could be 10, but it could be something else depending on the problem, if that makes sense. Like in that specific instance, it was 10, but they're not saying it's constantly 10. It's a changing 10. It happens to be 10 at that moment. So that's why you wouldn't plug it in then. Does that make sense?
Yeah.
Okay. So we're taking the derivative of like the formula as opposed to taking the derivative of that specific instance. Okay. Yes. Good? Okay. So when we take, are we listening still? Hey guys. When we take the derivative of this, I do not want to have to do a quotient rule if I don't have to. So I'm going to rewrite that as 6s to the negative 1, just to make it a little easier. I like to be tricky. Okay, so how do we find the derivative of the left side?
Cosine.
Yeah, cosine. So we're going to say that's cosine theta, and we just took a derivative of theta, so what should we say? D theta dt. Good. Mm-hmm. So this is us where we're adding in the part about how is the angle changing over time. And then if we take the derivative of the right side, what do we get? S to the negative 2. And then you're right, ds dt. Mm-hmm. Okay. Now, let's go ahead and start plugging our numbers in. So we took the derivative of the whole thing, and now we got some things to plug in. So we do know what cos theta is, right? Because we do have that triangle. So what's cos theta? Cos theta would be adjacent over hypotenuse, right? 8 over 10 for this specific instance. Now we can use our specific numbers. So cos theta would be 8 over 10 d theta dt. And then we have negative 6. And what is our s value? 10. And I should be writing these units in here. I'm going to go back and put my units in. Sorry. To the negative 2. And then ds dt is negative 400 miles per hour.
See, my problem, I think, is going to be recognizing those in the problem. We went out here, we already knew what BT was off the bat.
That you knew it already? I would say, to be honest, when I learned these, I had a really hard time with them. And when I came back to make notes on them, to then teach them, I was still struggling with them. And those like helpful hints that I wrote down, those kind of helped me if I went back and really did the problem using that list of things each time. And I was just like real careful on these not to jump into the problem immediately, but to like think before I kind of wrote each step. And then you really just kind of have to practice them. And I will say though is I've already worked through all the answer keys, and you'll start to notice there's some problems that start to get repetitive where it's like, oh, we've done this problem already. So at first they're going to be harder, they'll get easier as it starts. You've seen that problem before, so now you're like, okay, the next time I do it, I'll do it like that. Yeah. All right, so let's go ahead and multiply all these numbers in here. Does it matter if the end parenthesis? No. No, the end parenthesis won't. I can type it in again with the.
It's politically correct.
Okay, I kind of lost track of my units on here, but I think the miles and the miles on this side canceled out. And then, well, this one, because of the -2, it'd be like, yeah, it would be dividing by miles squared, so it'd be like miles hours on the bottom.
So it would be miles per hour squared? Instead of miles squared per hour, 4 hours? 30 hours.
I don't, this is weird. This is odd. I think it would be, because this would be miles squared, but it'd be on the bottom of a fraction. Do you guys see how that would be because of the 2 there? And because it's negative. So that would be like 1/10 miles squared, or 1/100 miles squared. That's interesting. Anyway,
Wait, you just have miles per hour.
I have no idea what's on the top. And the thing is, if you think about this, the answer would need to be in something that you measure angles with. And when we do calculus, we do radians. Even though this is a triangle, we always put our answer in radians. So this might be one I might have to go ask on. So, but we do know, if you think through this problem, for the most part, when you put your units in there, you'll be able to tell what the final units are by the answer. On this one, I'm just kind of thinking like, I'm trying to describe the rate of change of an angle measurement, and so my rate of change is going to have to be like radians per hour, or like degrees per hour, or something like that. Yeah, and miles per hour and miles per hour and miles, that's not going to get you to an angle. So I might have to ask on that one for you guys. So, but anyway, we can get the number though, right? So how do we get the d theta dt all by itself? Yeah, so we're going to say 24 divided by, when you divide by 8/10, make sure you put that in parentheses so you get that right.
I thought it was just like here and stuff. Forgot to
I really don't know what they would be.
Yeah, well, the teacher that I borrowed / stole these problems from, she put radians per hour, but I'm not feeling convinced about that. I'm not feeling very convinced. We might have to readdress this one.
I have a question about the next one.
Okay, yeah, let's.
Our conclusion would be
The 30 is right. The 30 is right. I'm a little bit not sure of the units, but I do know that the answer is right. So then we would say the rate the angle of elevation is changing would be 30, probably degrees per hour is what I would say, but this other teacher is really brilliant, and I don't want to just straight up say she's wrong. She's possibly not, so. Okay.
So why don't we just drop the units?
There's gotta be units. Just put one or the other. It's gonna, we're not sure. We gotta have units. It doesn't make sense if you don't have any units. All right, let's maybe move on to the next problem. Are you guys okay with that?
One person drinks soda and a
Now I almost wanted to change this problem because I feel the same way about this. I probably wouldn't drink soda out of a cone cup either, but maybe if you had just had like a little slushy thing, like the little ice and snow cone, and then you're like drinking the little soupy part after it melts. Maybe let's pretend.
That's crazy. That's soda out of a cone.
Maybe let's pretend that's what's happening. I don't know.
It's like pouring your milk before your soda.
All right, so
What? Pour your milk before your soda.
so there's our cute little cone. Go ahead and draw your cone. All right.
I should have made it bigger. I didn't know. Yeah, physics did get me right.
All right. So if we look at this, it says we have, if you're talking about some liquid that's in the cone, then we're probably talking about volume in the cone, right?
Yes.
And if you have your volume in the cone, we want to look up what the volume of a cone is. And the formula for that is 1/3 pi r squared h. So in the problem, they told me that the diameter of the cone was 8. But it is probably going to be more helpful for us to just write what the radius of the cone is. So I'm going to go ahead and say the radius of the cone is 4. And I'm going to say the height of the cone is 10.
Well, I thought the height of the cone was 15. So that the soda is...
Oh, the soda is 10 meters deep. Ooh, centimeters. Thank you for pointing that out. The whole thing is 15. And we are looking at when it's 10. That was good. Good catch. And I'm going to go ahead and write centimeters on both of these. I'm keeping track of my units. If it makes you guys feel better, I will say that example we just did where I couldn't figure out the units. Of all the problems I've done the past 2 days of these, it's the only one I've ever not been able to figure out the units on. So that means that for the majority of the time, you'll be fine. 15 is the height of the whole cup. This 10 is the height of the soda inside the cup. Yeah.
Doesn't that mean that the radius isn't necessarily 4 at 10?
Yeah.
Facts, it does.
Okay, so let's not write the radius. Well, yeah, no, you're right. Okay, so it says he is drinking. He is drinking at a rate of 20 centimeters per second. So that 20 centimeters per second that he's drinking is going to be changing the volume of what's in the cup, right? So the way we write this is we say the volume in the cup is changing in relationship to time. And if he's drinking it, that volume is no longer in the cup. It's decreasing. So we're going to write this as a negative volume. So we're going to say negative 20 centimeters cubed per second. All right. And the thing that we are trying to find is we want to see how fast the soda level is decreasing. And so what is it that we're actually trying to solve for?
I mean, H.
Time?
But it's not actually H. It says how fast is the level decreasing. The H dt is what we're trying to find. Mm-hmm. Okay. So if you look at this problem, you'll notice, listen carefully guys, we know that we're about to have to take the derivative of the volume, and the reason we know that is because the derivative of the volume is one of the things they gave us. That's a piece of information we have, so we're going to have to use that somehow. The problem with this is that they didn't really give us, we don't know what the radius is when the height is 10, and we don't know that the rate that the radius is changing. Those two things are completely left out of the problem, which means that this R in the problem is an issue. We don't have anything we can do with the R right now. Does that make sense? So if you look at this, we have kind of like a right triangle here, where we have a 4 for the little side of the right triangle, because that's the radius, and then 15 for one side. So what we're going to do is we're going to write down the relationship between those two sides of the triangle as a proportion. All right, we're going to say that the relationship in a right triangle is going to be the radius to the height. And in this particular picture, it is 4 to 15. And that allows us to set up a proportion that relates the R value to the H value. Because remember what we said, if we had two variables, we needed two equations to help us narrow down and get something in terms of one variable. That's essentially what we're doing right now. We can't have two variables in this problem because we don't know anything about that R value. So I'm going to say that my proportion is R over 15 is equal to 4, R over H is equal to 4 over 15.
If that's a changing situation, how come we don't know what DR?
Well, because they didn't tell us DRDT. They literally never mentioned it in the problem, and so we're not going to be able to use it.
So at some point, will we solve for it?
At some point, we could. If they asked us, we could. But we don't need to because they didn't ask us. Okay. This is one of your guys' favorite things. If we have a fraction equals a fraction, how do we solve? Cross multiply, yeah. So 4h equals 15r. And we're not going to solve for h because we like the h in the problem. The h is the stuff we are interested in. We want to get rid of the r in the problem, so that means we want to solve for r.
That's actually what I meant to say. No, look, I wrote that before I asked the question.
All right. So before I go and get the derivative of this to find my dv/dt, before I do that, I'm going to go ahead and get the r out of the equation by taking this and plugging it into the equation. I'm getting rid of r. That's my purpose. So I'm going to say that my new volume equation is going to be 1/3 pi. I'm getting rid of r. And I know that this process feels a little bit confusing, like, oh my gosh, I never would have noticed that right now. But when you see the next cone problem, you're going to have an opportunity to do the exact same process. So it's not going to be different next time, it's going to be the same next time. All right, so you'll be able to do it that time as well. Okay, so let's fix this a little bit, and then we're going to have to find our derivative. So if we do 4/15h and we square that, what happens to the 4/15ths? 16 over... This is a great time to use your calculator.
225.
225. And if we do 16 over 225 and we multiply that by that 1/3, what does that give us?
Does that give you 16 over 675? It's a guess. I don't know.
Yeah, 675. Is that what you said? 675?
Yeah.
Yeah, that's right. That's good. And we can go ahead, we can keep that pi there. And then this was an h that was being squared, and it's being multiplied by another h. So h to the third. Okay. So we just fixed the volume. We got it. So it was only in terms of h. Make our lives a little bit easier. And now we can go ahead and take the derivative of the entire equation. So what is the derivative of v? It's just dv/dt, or you could say it's 1 times dv/dt. That would be fine. And then what's the derivative of this part right here? We would move the 3 to the front, right? So it'd be 3, and these numbers just stay here, right? Because those are like the coefficient.
Okay, but I thought it was just a part of h.
So they're the coefficient in front of h, and if you remember how it works when you just multiply it in the front. So we took that exponent, we brought it to the front, we dropped our exponent by 1, and then what happens after this? dh/dt. Because we took the derivative of an h, so we got to say dh/dt. Okay. So at this point, we can replace the stuff in the problem that we know the number values for. So dv/dt is what? All right. And then here we can do 3 times 16 over 675, which I think brings us back to 16 over 225, right? And we can plug that h value in, the 10 centimeters squared. And then dh/dt is what we don't know. And then we can divide. And if you do not want to multiply these out before you divide them, that's fine. We can go ahead and just like divide all that stuff, and you can do it pretty nicely in your calculator. Oop, don't graph it. So if you do alpha y equals, then you can just type it in exactly the way it looks. So negative 20, and then it would be 16 over 225 times pi times 10 squared. So I'm just typing in this on top, and I'm dividing all this stuff over. Yep, I just took this whole chunk of stuff that was in front of the dh/dt, all this stuff, and I just divided it over. Yeah, the whole thing.
Then what happens to the units?
So if you think about how the units would work, and we can go ahead and write it if you want. 10 centimeters squared would be 100 centimeters squared, right?
Right.
So that's what I got when I divided it. So my number is approximately negative 0.895. Is that what you guys got?
Yep.
Yeah.
And then if we pay attention to our units, centimeters squared on the bottom is going to cancel with 2 of the centimeters on the top. And then our units would just be centimeters per second. And would that make sense for our height to be changing by centimeters per second? If you think about it. Well, the volume dV/dt was something that we did know. So in the question, they were saying, like, how much is the height changing by? The unit shouldn't be volume because they're describing a height, which would be 1 dimension, not 3 dimensions. Yeah. So centimeters per second actually makes sense for our units.